Hello everyone, this is Sean again with Surviving Networking in IT. And today we're going to talk about something that some people get a little confused, and that's Mikrotik VLANs. And we want to help someone be able to configure this. And a fellow member on our Discord, them MCV, wanted to know different ways to connect devices via VLANs in a simple method as much as possible. But let's get the elephant out of the room of what VLANs are and are not. VLANs are essentially a way to divide and split traffic that is riding on a single cable or single piece of wire. And the best way to relate to this is cable TV channels. Your cable TV provider sends you 200 cable TV channels to your set-top box through a single coax cable, and then from there that set-top box can output one channel to your TV. And when it does that, it allows you to be able to pick and choose what you want from that. Essentially, that's what tagged and then, of course, down the line, untagged traffic does. The tagged traffic is all those channels available to you to be subscribed to, and then the untagged is the one channel that goes out to the TV. What VLANs are not. VLANs are not a tool by themselves. They enable other tools for better overall security. So firewalls work with interfaces, and you have to have interfaces for firewalls to recognize it's coming from one thing to another or routing from one subnet to another. It's debatable that you can actually have multiple subnets on a single interface, but for the sake of argument of most manufacturers, you can have one subnet per interface. Firewalls block from or can allow traffic on one interface to another, and VLANs enable that functionality. So if you want to separate your executive users from your standard warehouse users, VLANs can make that possible. Let's talk about more of how Mikrotik treats VLANs. So there's three aspects of Mikrotik that treats VLANs. There's VLAN interfaces, and in Mikrotik's world, an interface is an interface is an interface. So it doesn't matter if it's a physical interface or a logical interface, such as a VLAN, a bridge, a bond, VPN tunnel. Interfaces are treated the same. With tagged traffic, it is sent over a wire as tagged. It adds a little 4-byte tagging header to the frame. And untagged strips any kind of headers away and assumes that data that's coming through is meant for that particular device. Let's go ahead and bring up GNS3. And we're going to talk about Mikrotik VLANs on a non-bridge port downstream to a switch. This is the easiest way to use VLANs with Mikrotik. So right now we have 2 sites. We're going to focus on router 1 today, and the 3 VLANs over here on the left that we're going to talk about. VLAN 10, VLAN 20, and VLAN 40. And essentially the head of the network is going to be router 1. Then we have 2 downstream switches that are common in a lot of homes and a lot of small businesses. So let me go ahead and get connected to router 1. Down. And we're going to ignore PC1 for now. Humor me, because I want to make this as easy as possible. VLANs can be super easy for Mikrotik or super pain in the butt. The super easy way is literally go into Winbox, on interfaces, click on VLAN, and create VLAN interfaces on the singular port that you want to trunk or send the VLANs to. So we're going to call this VLAN 10. And we're going to set the VLAN ID to 10. And we're going to put this on Ether 6. And we're going to do this for VLAN 20. Duplicate again and do this for VLAN 40. And now we have VLAN 10, 20, and 40 on a singular interface below Ether 6. That means right now we can send tagged traffic on VLAN 10, 20, and 40 through Ether 6 over to a switch. That right now is connected. Ether 6 is connected to Ether 6 on the switch. But if we're going to use any kind of resources in routing, we probably want to add IP addresses to these VLANs. So let's go ahead and do that first. 22.168, let's say 10.1/24. Add this to the VLAN 10 interface. And we'll go ahead and duplicate this and keep on going down the road. Hit again, VLAN 40. And now we have 3 IP addresses for those 3 interfaces. Now remember, Mikrotik treats interfaces the same no matter if they're virtual or otherwise. So Ether 1 has an IP for the WAN access, but VLAN 20, 10, 20, and 40 could be essentially different ports on a router. That's how Mikrotik treats it. And we're going to go ahead and set up DHCP servers for those 3 VLANs. So DHCP server, setup, choose VLAN 10, and we'll hit next all the way through. That quickly creates the DHCP server for that. And we'll do that for the 40 VLAN as well. So now we have 3 DHCP servers set up for VLAN 10, 20, and 40. Now, if we have our other connections right, go to switch 1. Let's try this again. Switch 1. And for Ether 6 and 7, we have for .1Q, which is basically tagged access or tag traffic. In this simulation, this is allowing all tag traffic to come through. Now, for a switch, we want to then untag when we head out to the PC. This is on Ether 1. So Ether 1, we have this set to VLAN 10 untagged as an access port. And then for Ether 2, this is going to PC 5. And this is going to be VLAN 20. So we already have that set up, ready to go. And we're going to check the other switch. On the switch, ports 6 and 7 are set up for tag traffic, which is .1Q. And we need to be for Ether 1, VLAN 20, which we have that set up. And now for PC 9, that needs to be on VLAN 40, and that's going on Ether 2, and that's already set up. So essentially, we have a VLAN 10, 20, and 40 that's homed on the router here. It's sent through Ether 6, then gets sent again down to this switch, and all the devices on these switches should be able to get access. So let's go ahead and start with this, PC3, PC5, PC7, and PC9. Have all 3 of these pulled up. We do DHCP to see if we get an IP on the right subnet. And PC3 is on the 10 subnet, which is for VLAN 10. Do DHCP here. And this is on the 20 subnet, which is PC5. This is also on the 20 subnet, which is VLAN 20, PC7. And last but not least is PC9. PC9 should be on the VLAN 40 and get a 40 subnet. And it does. Now, the great thing about VLANs is that if you have your switches connected correctly, once the devices have an IP, you can literally click on or remove the wire between the router and the switch. And PC3, which is on this right here, I'm sorry, let's do for PC5. PC5 is on switch 1, and PC7 is on switch 3. And I'm going to go ahead and grab this IP right here. I'm going to try to ping it from PC5. I can ping successfully from PC5 to PC7 on the same VLAN, no problem. However, even though PC3 is on the same switch as PC5, I will not be able to ping it because the switch is not doing the routing. So PC3 needs to head to the router to get to PC5. And if we try to ping it, we're going to timeout or not reachable. This is confirmed. This is copied right here from that. All we have to do is reattach the connection. And we repeat the same process. Try to ping PC5. And look, we are able to ping to a different device on a different VLAN. Some manufacturers do not allow IP forwarding or cross communication between two different VLANs by default. That's something that Mikrotik does allow by default. Your mileage will vary. So right now, all of these devices should be able to ping one another. Let's go ahead and let's see if I can ping this device from PC3. So this is PC9, so PC3 is on the first switch on a different VLAN completely, and it's going to try to ping PC9 down here on VLAN 40. And I'm able to successfully ping that. Essentially what's happening is the PC is going here to the switch. It says, hey, this is not on my same subnet, so it heads to its default gateway at the router. The router then routes it to the other VLAN, back down this switch, back down to this switch, and to the PC. And that's how they communicate back and forth. That's the easiest way to set up VLANs. The more difficult way is you can use bridging ports and use your Mikrotik as a switch. But I don't recommend doing so because most places use their Mikrotik as their router, unless you've bought a Mikrotik specific switch. Let me go ahead and bring over here a router that I have configured like a switch. Let me go ahead and pull that over. And we're going to connect Ether 7 to Ether 1. And I'm going to go Winbox into this and show you an example of what we can do to get that connected. Okay, so Ether router 3. So I went ahead and earlier and added the VLAN interfaces. They're connected to Ether 1, which is feeding from right there. I've already created a bridge, but I'll go ahead and delete this and explain how this works. So essentially, we want to bridge VLAN 10 to ETH whatever 2, and essentially they'll create an untagged traffic through from VLAN 10 to ETH 2. We'll go and create a bridge. Let's call it vBridge 1. And we go to ports, to Ether 2, and literally VLAN 10. And essentially this is going to funnel traffic that is flowing over Ether 1 into VLAN 10, and from VLAN 10 to whatever out Ether 2. Let's go ahead and get another PC here. We'll go ahead and tie this together. Ether 0, 2. Start this. And console over for this PC 11. So PC 11, we're going to do DHCP. And literally is able to jump on the same VLAN as PC3 up here. And that's all because of how the bridging works right here. Now, I don't recommend doing this because this creates bad habits unless you have a Mikrotik dedicated switch. If you're using onboard resources such as DHCP or other management functionality tied to this, it won't end well. Had some bad experiences with it. So we'll go ahead and close this out. We're going to nix this PC here. We're going to go ahead and disconnect this router, move it over here out the way, and bring up router 1. Let's talk about Mikrotik tagged and untagged VLANs on a bridge and their interactions with the CPU. So if you want to have a scenario like this where you have a PC connected to the router and everything else is downstream to a switch, you have to reconfigure VLANs completely from scratch. By completely from scratch, I mean it significantly different. And I'll go ahead and explain. So we have to first create a bridge. We're going to call this VLAN bridge. VLAN bridge. We're going to turn on VLAN filtering right away. If you are using a port, which is going to be a part of this bridge to configure the router, I recommend keeping that port separate for now until you get this all flushed out, because you can instantly get cut out as soon as you turn on VLAN filtering. So using safe mode may save you a little bit. However, it'll prevent anything you've just changed from saving. I recommend using a dedicated port for configuring management when you're starting with VLANs. So we've already created the bridge. We're going to create some ports. I'm going to add all the ports here. So Ether 2. Add Ether 3. Ether 4. Ether 5. And we have one more for Ether 6. Now, once you add the ports to the bridge, I go back into the port and go to the VLAN, and we have to set the PVID, which is basically the VLAN ID that this needs to be untagged for. So this is going to be for PC1 on Ether 3. So we're going to set this to VLAN 10. And we're going to jump over here to VLANs. And it's dynamically created a VLAN entry for Ether 3. Now, one may think, hey, that's enough to get going. Unfortunately, if you're using CPU resources for this access port tying into the VLAN, you actually have to add the bridge that you're on for tagging. It's confusing. I'm unsure why Mikrotik chose to do this, but it's something I've learned you have to do. So I'm going to copy the entry and just add the bridge, apply. And now it shows VLAN bridge is tagged and Ether 3 is untagged. With any luck, I should be able to switch over to PC1, do a new DHCP, renew or start, and I should be able to get an IP. Okay, that's odd. Let's try this again. Console. All right, PC1. Let's go ahead and DHCP. And know why. I was going a little too quick. So I've created all the bridge information for right away. However, what I needed to do first before anything else is that the VLANs have to be moved underneath the VLAN bridge. So let's go ahead and move those over. And now this should work. Voila. Now PC1, which is attached to E3. Yep, it's part of Ether 3. Is now connected to the VLAN 10 network and got an IP from the DHCP server. Let's go ahead and add the rest of the ports that we need. So we've added the VLAN bridge. Now we have to add the Ether. Actually, let's see what we can get away with. I don't know if I've tried this yet. Do need to add additional VLANs, so VLAN 20 and 40. 20, 40. And we're going to go to PC9 and see if the VLAN's passed down. It may or may not. I don't remember if I've tried this before. We'll go ahead and give it a shot live. PC9. DHCP. Okay, it does not. Didn't think it would, but wanted to give it a shot. So now we need to flip back over to Winbox. We're going to add the ports. It's going to be tagged Ether 6. This is also going to be tagged Ether 6. VLAN 10, because we want to have that go down to PC3. And let's try PC9 again. Survey says, hey, what do you know? It's going to work. So, PC9 has an IP on the 40 VLAN again. This should still be able to ping other devices. So, 192.168.20.48. And I'm able to ping from PC7 to PC5. And I bet PC1 can ping everything. 2.168.40.251. And I can ping from this PC on VLAN 10 down to VLAN 40 just fine. Now, in luck, I should be able to get out to internet because I already have NAT set up. And this PC can get out to internet along with this PC down here, PC9. We have 3 VLANs. We have 3 VLANs on 3 different devices. PC1's on just the router itself. PC3 is on the switch on VLAN 10. So these are same VLAN together. PC5 is on the first switch. PC7 is on the other switch. Both part of the same VLAN. And PC9 is on the last switch, of course. And they can all communicate together. Now, just say PC9 was a VIP, and you did not want anyone else to be able to communicate with it. Mikrotik treats this very simple. You get a firewall, and a firewall rolled on the forward chain, and you can either target an interface, or you can target a subnet. I'm going to go ahead and target a subnet. So let's go ahead and say coming from 192.168.10.0/24. That means everything in VLAN 10 going to 192.168.40/24. You want to drop it like a bad habit. Okay, so we have this this firewall rule set up. And we're going to go to PC1. PC1 can still ping out through the internet. But PC1 cannot communicate with PC9. It's being dropped by the firewall rule. We see it right here. Packets are counting up from it. However, PC9, of course, can ping the internet. See what the IP of this is. Okay, so we're going to grab this IP and see if PC9 can ping the PC1. Now, it cannot. The reason why is that firewall rule, the way it stands right now, will not allow replies to happen. However, you could throw data to PC1, but the PC1 is not able to reply to the ping response. We can set up another rule which will allow that to work. Go to the forward chain, say connection type. Oh, no, sorry, not connection type, connection state. Established or related. These are all or, not and or. So if it's or established or related, we're going to accept. And we put this atop of our firewall rules. Go back to PC9. Now PC9 now ping PC1, but PC1 still cannot ping PC9. This allows administrative access in a one-way direction, which is very valuable in an enterprise environment, but it also might be valuable to you at home. So if you have an IoT VLAN that you want to set up, you want to be able to get access to those IT devices from your own main VLAN, but you don't want the reverse happening, you can set that up with this. In any case, as you saw, sending traffic through switches, other managed switches, is a lot easier and is very, very fast to get going. You can get set up in 4 or 5 minutes. I've done this before at a couple of different enterprises. I've also done this before at home, and I recommend using that method if all possible. If you try to use the other method where you're combining both the ports on the router itself to join that VLAN, you might want to ask yourself, is that device important to be on that same VLAN as another device? You may just want to have a separate network, and that will work just fine. Again, in Mikrotik's world, interface is an interface, and routing between them just works. Anyways, this is Sean signing off from Surviving Networking and IT. And if you have any questions, please join the Discord, and we'll do what we can to help you out. Thanks. Bye for now.